What we need to do now is define a force, or forces. Forces are a push or pull on an object by an agent. So a force is some type of, if you're thinking of a person, and there's a block, they can put their hands on the object and push the object, or they could attach some kind of rope and they can pull on the object. So this side is a push and this side is a pull. And the agent is whatever is supplying this force. So in this case it would be like the person's hands on the box, or this case it would be the rope attached and the person's pulling the rope. Now, this type of forces are what we call contact forces. These are where you actually, lack of a better term, make contact, right? Direct touch between, or touching the object. The other type of forces that we have are long-range forces. But long-range forces we see more often in electricity and magnetism, where if you have two negative charges, let's say, the negative charges repel each other. So in this case, this charge pushes on this charge, but there is no direct contact. So long-range forces work without indirect contact, and this would be the push side of a long-range force. And if we had a positive here and a negative here, this positive would be pulled now towards the negative. So long-range forces are ones that work without direct contact. Contact forces are direct touching, and we're going to look at many more contact forces than we will long-range forces. A force is a push or a pull on an object by an agent. So the agent is the thing that's supplying the force, the object is the thing that's responding to the force. Now another thing about a force is, forces are vector quantities, need to be treated like vectors. That means whenever we have some type of force, we are going to have some type of arrow that we'll put onto, with an arrow over the label. You'll have some angle associated with it, and you'll be breaking your vector up into Fy and Fx. The idea is that Fx will be the F cosine theta, and Fy will be F sine theta. And whenever we want to study our forces, we'll be breaking them into components in the x's and the y's, so we can see the effects on motion in the x and the y, because they have to be treated as two different directions. So forces are vector quantities, and we have to treat them as vectors, which means we'll be breaking things into components and studying motion in one and two directions as the result of our forces. It turns out forces are going to be responsible for changes in velocity. And because we're saying changes in velocity, this indirectly means accelerations. Introduction to the idea of a force, that it's a push or a pull on an object by an agent. Smiley face. All right. And they're a vector quantity, and they're the things that are responsible for changes in velocity. There's two categories, contact and long range. Contact means direct touch, and long range is indirect, where there's no actual touching. And then we said that because of this vector quantity, we have to treat them with all our vector properties, breaking into x and y components, and then once we have our x and y components, we can study the results of the motion in x and y direction.